Hello everyone, welcome to day 2 of System and Skill Summer Edition. I'm Yun, host of the event. Last week, we have a great kickoff with focusing on reliability and overload resilience. With that covered, today we will move to another important problem domain, multi-tenant resource management at large scale. In this area, Kubernetes has emerged as a de facto cluster management solution. Even though it has greatly simplified the resource management operations, hosting a huge number of KAS clusters in public cloud still have some unique challenges. Our first speaker today is Qi Ke from Microsoft. Her presentation is about how Windows Azure manages 1 million Kubernetes clusters. Let's welcome Qi.
Hello, everyone. My name is Qi. I'm the Engineer Director of Azure Kubernetes Service. Today, I'm bringing the talk from Lake Sammamish in Washington State. Hope you will enjoy it. A little bit more about myself. I've been working in the cloud industry for over 10 years now. I have been hopping between Microsoft and Google a few times. In each hop, I have been chasing something new. 3 years ago, I rejoined Azure to lead the managed Kubernetes service effort. Since then, I have been very lucky to work closely with Brendan Burns, Gabe Monreal, and many other cloud-native folks in this area. And today, I'm going to focus on sharing the challenges we have experienced in the past and we are still experiencing in managing large number of clusters in the cloud. So here's the difference. It's not about managing large clusters, but large number of clusters. Large cluster is a challenge itself. I can leave it to the future talk. But today I'm going to focus on how to manage large number of clusters with efficiency. Whenever people think about Kubernetes, the first thing come to their mind is, isn't Kubernetes supposed to make things easier? It is cloud native and it's supposed to help the cloud native workload, right? But things are not that simple. First of all, we are serving the managed cluster to all Azure users. That means they can bring in a diverse requirements and a wide spectrum of workload onto the cluster. Then, as Kubernetes is born cloud native, it does bring new challenges to the cloud providers. In the past, cloud providers are more facing more relatively static workload, and now Kubernetes make it much more dynamic. Then Kubernetes is successful because it's flexible and extensible, such as through CRDs and controllers. However, this flexibility and extensibility can bring in complexity, especially for the managers managing these clusters. Last but not least, the workload errors. These account for more than 50% of the tickets AKS receive. To help explain my talk today easier, let me first set a very simple example, a simple illustration of how AKS works, so you can understand the terminologies in the later part of my talk. So AKS is a multi-tenancy system. We host the customer control planes in a shared infrastructure that AKS owns, like we own. And then when customer create a cluster, we first create the control plane onto our shared infrastructure. So control plane include API server, scheduler, controller managers, and etcd. And then we also create the workload, but these workloads are created in customers' subscriptions. And then we join customers' nodes, which are the VMs. We join in the future. They can be actual host or customer node. But for now, it's VMs in Azure. And then we join these workloads into the cluster. So first, let's talk about the diverse requirements. Some examples. We serve customers in many industries. The bank industry, the customers are super sensitive about security and compliance. They don't want anything exposed into the internet, including their own control plane. So they require private clusters. And then for gaming industry, they are exactly the opposite. They even want the public IP per their workload, so they can have max number of SNAT port for their customers to connect to. And then there are customers who want a planned maintenance window, meaning that they do not want any change happen to their cluster during this time, such as Walmart during the Black Friday time, as you can imagine. But there are also customers who are saying, well, I have so many clusters to manage. I just don't want to manage each of them when it's time to upgrade. Please go ahead and do auto upgrade for them in case there is a CVE, you have new patches for bug fixes or security vulnerability fixes. Go ahead, auto upgrade whenever you can. So things like that, as you can see, pose a big challenge for our test. We have exploded test matrix to verify, and it's just simply not feasible and possible for a small team to handle all of them. So we have to rely on production to some extent, but that can lead to outages. A very recent example is we switched from NTP to Chrony, but by mistake, we have to pull down the image at the node provision time from Ubuntu. And this broke some of the customers who block the Ubuntu URL for pulling down images. That's one of the IP whitelisting feature, and unfortunately we broke that. But we quickly detected and reverted. Next, Kubernetes brought new challenges to cloud providers. Why? So before Kubernetes, customers deploy workload into VM in a relatively static manner, meaning that, I'm going to run these processes on these VMs, and it's predetermined. However, in Kubernetes, these are all dynamic. Thanks to the scheduler, Kubernetes achieve higher bin packing, and Kubernetes can dynamically schedule and move workload, which is pod, from VM to VM. Pod workload become ephemeral. However, this can bring down the whole cluster. For example, a rogue pod can bring the whole cluster down by killing the VM one by one. And later in my demo, I will show you how that could happen. Then with auto-scaling, with all sorts of auto-scaling and auto-remediation functionalities, Kubernetes is also constantly calling the control plane operations against the cloud providers. And usually in the past, cloud provider might not design their control plane as scalable as their data plane. However, this makes their control plane, this pushes the cloud providers have to scale up their control plane to deal with the frequent polling and frequent changes. Flexibility and extensibility. So in running the managed Kubernetes service, we use a lot of open source component, which is very nice because we don't have to develop them one by one. However, bugs in open source softwares can be costly to fix. Here is an example. There is, you can say, a bug or debate on resolved behavior in Ubuntu since 18.04. It's a changed behavior. So customers were surprised, including us. We were surprised, and it didn't work well for our customers. However, this bug has been there for 2 years, and right now it's still the authors and the audience are still debating about the fix or the behavior. Even worse, because of this, we have to turn off resolve D. But when we turn off resolve D, we didn't notice that some of the DNS resolution will take longer than before. And because of that, we hit the timeout issue when we create a new cluster. Then customers can add components because of the flexibility, because customers demand that, or because we are not fast enough to add these features. So we give these knobs for customer to turn. But when we give these knobs to customer to turn, their components or their configurations could interfere with managed ones and deteriorate the managed experience. Here are a few examples. The scheduler. Kubernetes allows you to write scheduler extensions to change how scheduling behave. But customer could write not performant or incorrect scheduling logic, which can make it hard for our engineers to debug when we get the ticket. Webhooks. There's admission webhook and mutating webhook. And if customers change these webhooks to decide how their workload are deployed, it could also be expensive and tricky for our engineers to understand why this pod is not deployed as expected. Another example is the DNS behavior. We allow customer to have customer DNS server or their configuration. But if they configure incorrectly, or if their DNS server is behaving incorrectly, that can result into DNS resolution errors. Pod disruption budget, that's another example. This is actually very tricky and had cost AKS a lot of time of debugging. This interferes with upgrade, especially. So during upgrade, AKS is trying to do it one node by one node, but to do that, we need to call down and join an existing node and push the workload into other nodes. If a customer didn't set the pod disruption budget correctly, that could get the node stuck forever without being able to join. And because of that, our upgrade will fail. Last but not least, as I mentioned, CRDs and controllers is a great way to expand Kubernetes capability. But they could also, for instance, they could also they could also result into incorrect behavior of the cluster. For instance, I mentioned earlier, they could DDoS the API server, have so much requests, all of them can be watching the API server simultaneously and leading to API server to go out of memory or out of the in-flight request quota. Workload errors are probably more than 50% of the ticket we received by the AKS support engineers. Most common one is resource overcommit. In the demo later, I'm actually gonna illustrate how easy customer can shoot them in their own foot by overcommit the workload into the system without knowing. Misconfiguration, as I mentioned quickly earlier, for instance, the core DNS and these places, or their webhooks or scheduler extension, they could have bug in the code or misconfiguration to make their cluster not working. Another example is the IaaS resource, such as the firewall rules or network security rules. If they configure incorrectly, if they happen to block the cluster, to block their VM to access their API server URL, their cluster will not be able to function. Policy is another common problem we notice. The difference between configuration policies, for configuration, the cluster admin usually themselves know what they did. But for policies, they didn't even know. They might not even know, because usually policies are configured by the subscription admin or security admin that is out of their organization. But these policies, if configured incorrectly, can also result into, let's say, blocking egress or blocking ingress, which makes the cluster stop functioning. Of course, unexpected load. If the customer only tests their application on a test environment without sufficient load test, when they push this to production, it could just get unexpected results, such as killing their API server out of memory or killing their core DNS pod and resulting to unexpected errors in their application. Or even suffer like SNAT port exhaustion is another common errors we have seen in customers' production workload. Now, how to manage these challenges without growing the team size proportionally? Here are a few. First, we try to build the guardrails, build the guidelines to help customers fall into the pit of success instead of pit of failure. Then we also enhance observability, meaning that we are going to share more of the metrics, more of the logging events data to customer. And also out of all these metrics and logging and all the signals, trying to pick out the signals that's most relevant to them, that they can take action on. We also do quite some. We also start to do some work in the more managed and opinionated experience. This is similar to GKE Autopilot. In fact, we have the work going on for some time, but we are debating on this fully managed experience or more flexibility left to the customer. But based on the challenges and issues I mentioned in earlier slides, we are going to go into more managed experience as well. Here's a few more things on how do we help customer fall into the pit of success. First, we'll have documentation, at least start with documentation of best practice so they can follow. Then we also have the VS Code extension, particularly for AKS, for for developers to interact with clusters from their IDE. And also to get the logs, metrics, and events from the cluster from their IDE. So they have one place to do both development and production debugging. Then we also have proactive detection. This is, I mentioned earlier, the detectors and remediators, so that we can detect if the customer's workload, the load is having problem, or their workload is having problem, or the configuration is having problem. And we are going to show them in the AKS diagnostic portal later in my demo. Then we also provide more guardrails, such as policies or webhooks to reject unqualified or bad workload in advance before these workload even get into the cluster. Next, I'm going to show you a quick demo to demonstrate what I mentioned earlier about the AKS diagnostics to help customer debug their production issues quickly. So here, I prepared the demo first. I prepared a pod, which is called, this is Kubernetes shell demo. And then I'm going to run some stress tests in the pod to show you what the customers themselves usually can do on the cluster to debug. So first, I'm going to launch the stress test to do a lot of I/O, right, against the node. And here, as you can see, I launched a lot of the process to write against the OS disk, and the load has picked up. The load has picked up, and let's see what does the I/O look like. I/O stat. Okay, so here the write bytes. We have get to about 42, but actually we have get to 42 megabyte per second write rate against the disk during my short period of testing. And here, if I launch it again, you can see that the pickup. So this is what the engineers themselves do on the. Did I pause it? Yeah. So here it gets to over 100 megabyte. The reason it's 100 megabyte is the VM type I created, the maximum, the VM type and also the OS disk I picked. The maximum write throughput is 100 megabyte per second. And I can also show you here on the Azure portal. This is also picked up here. I have created a custom dashboard in advance to capture the disk write speed. As you can see during my test, the metrics pick up in almost real time, and the number of operations. So here we provide customer two ways. One way is in the cluster, they can examine what's going on and which process is generating the load. Then on the Azure portal, we are also showing user the single pane of glass across their VMs, across their clusters, how it is doing. Next, I'm gonna launch another load test that's gonna make the node go out of memory. From this demo, I want to show two things. One is if you do not set the request and the limit on the pod, on the containers, when you create them, you could get the node killed because the pod itself can use up all the memory on the node and then get the node into non-schedulable state. That's where earlier I mentioned that a rogue pod could kill your whole cluster because it can kill the node one by one. Here we go. We have seen that the pod has exit with status 137. And if we take a look and the pod, the status is evicted as expected, because this is the way that Kubernetes is protecting itself. And here you can see in the error code, in the event that it got stopped because the node was no on memory. Now, this is how you can debug on the cluster. But for engineers who are managing tens or hundreds or even thousands of clusters, to do that one by one is not feasible. So AKS provide this single pane of glass for engineers to come and examine at a glance what's going on in their cluster. Here you can see we are showing 3 alerts. The first alert at the bottom here is resource limit not set. This is what I mentioned earlier. The shell demo pod I deployed didn't set the request and limit. Because of that, when the container is using too much memory in the pod, it result the whole node to be low in memory and result into some system pod got evicted as well. And this is the second insight we see here, OOM killed. And if you will see, interestingly, it's not the shell demo that got OOM killed because the shell demo didn't set the memory limit. That's why it didn't get OOM killed. It is other pods which set the memory limit got OOM killed. Like this is a system. This is a kube system pod. And when this happens, your cluster can go into a very bad state, non-workable state. And lastly, I want to quickly show this one, the cluster node issue. So we also actively monitor the node. This is reported from the node problem detector that I mentioned earlier. And we have this plugin to detect what's a problem to the node. Here, it clearly reports this particular node is having memory pressure. So this gives customer actionable alerts that they can go in, investigate, and fix their workload, and then fix the cluster. The metrics and the logging and the events are a critical part of the journey. So AKS did a lot of work to enhance observability for customers. I'm going to share a little bit journey of what we went through. Initially, when we just launched a product, we have like a few hundred, not maybe less than 1,000 clusters. So we just had one prober globally to iterate through all the clusters. And quickly after we GA, our usage picked up exponentially. We quickly realized that's not sufficient. So we break it down to 1 per region. And then some of the regions expand so quickly that it goes into like tens of thousands of clusters per region. And obviously, we cannot just have 1 per region. So we quickly expanded into 1 per underlay. As I mentioned earlier, 1 underlay is the infrastructure to host customer control planes. And the good thing is it's the max number of control plane hosted per underlay is a fixed size. So this gives us predictable latency to iterate through. However, we are still not satisfied. So recently we changed to 1 per customer cluster. We deploy the Prometheus containers into the customer control plane so that it can collect the metrics instantly and stream to customer. This, we did a lot of tuning because we all know Prometheus is quite heavy. We did a lot of tuning to limit the memory and CPU consumption from this container. But next, we also want to monitor the metrics, to collect metrics and the logging from customers' node, as well as other cloud services to provide the full image of what's going on in the cluster to customer. For instance, very often customers step onto the SNet port exhaustion problem from their load balancer. And because load balancer is a critical part of the whole experience, we will provide that information to customer as well. What's next? We have two big group of customers. One, very experienced and want to configure their cluster whatever they want, and another group are more want more managed and opinionated experiences, so that they do not have to manage the infrastructure and the configuration of cluster. They make less mistakes. So for those customers, we will enable more auto scaling and auto configuration. And we are going to have more detectors, of course, and remediators to help them to provide actionable alerts to them. And we are also going to lock down the infrastructure so they have less chance to make changes that could lead to failures. Okay, so that concludes my talk. I hope you enjoyed it, and thank you.